So in this experiment, we're going to be doing a whole bunch of different double replacement reactions using an assortment of different reactants. And you're going to be looking to see whether or not a precipitate forms in each of these different reactions to ultimately try and identify some trends in when does a precipitate form and when does a precipitate not form. So I have my reaction grid set up here that is going to allow me to systematically combine all the different pairs of reactants that I want to do. So right now I have a sample of each reactant by itself along sort of the outer edges just for reference, so you can see what they look like before reaction to compare that to after to see if anything really happened. So what I'm going to do now is to put a couple drops of the reactant at the top of each column in each box all the way down. So we'll put silver nitrate in this one and 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 this one, and do the same thing with the other ones, and then same across the rows. That sodium chloride will go in each box across, sodium iodide, etc., all the way down. So at this point I have one of my reactants in each square. I've put the one at the top of the column in each box all the way down for each of these 5 reactants, for silver nitrate, lead-2 nitrate, barium nitrate, copper-2 nitrate, and iron-3 nitrate. So now I'm going to add the other one, and we will see what happens when our reactants combine. So you're going to be looking at each reaction individually to determine whether or not a precipitate formed. So remember that when a precipitate forms, it makes the solution cloudy or completely opaque. So you can see in a reaction like this one here that you can't see through that bubble anymore. It's blocking the black line behind it. So that is definitely the formation of a precipitate. Whereas over here, this one's still quite clear. So we'd say that there's no precipitate there. Some of them are going to be kind of on the fence cases, and I'll post close-up photos of each of these. But do remember that it's that cloudiness that you're looking for. So for example, one like this, there's a color change that happened. So there was some kind of chemical reaction. We went from this light orange to a darker orange, but it doesn't look like there's a precipitate there. It doesn't look cloudy, it's still crystal clear. So be careful of that. that what you're looking for specifically is precipitate formation, is a cloudiness, or that your solution is now opaque, not just that something changed.